and that topic is known as free fall motion. Right, so today we are going to talk about the concept of free fall motion. Let's suppose if you hate someone, if you want to try this experiment on that person, so you may try this experiment on that person by pushing that person from the top roof, right? Okay, so starting from the free fall motion. So in free fall motion, we need to discuss about the free fall concept. Like in this chapter, we are not going to talk about the forces, right? We already discussed that concept, that no force quantity is going to be involved in this chapter, right? So that's why we are only talking about free fall motion. So for free fall motion, let's suppose if we consider example first, then we write the topic and the points related to the free fall motion. So let's suppose if we consider an object placed at some height over here. Let's suppose if we consider a ball which is placed at some height. Let's suppose at this point. So ball is placed over here, right? And initially, if we want to write about the velocity, so you know that the initial velocity is equals to 0, right?
Yes.
And when we try to just drop this ball from this height, we are not going to throw this ball, we are only going to drop this ball. So when the ball is dropped from this height, so after some time, let's suppose if we consider that ball at this specific point, like this. So if we talk about velocity and acceleration, because in this chapter we talk about velocity, acceleration, speed, distance, displacement, time, right? So we only going to talk about this concept. We know that distance is already covering from initial till final point, so we are not talking about that. We are interested in velocity and acceleration. So if we want to write about velocity and acceleration for this ball, so what do you think, that velocity and acceleration will increase, decrease, remain same, or what happen?
I think the acceleration will increase
Okay.
and the velocity will also increase.
Yes, because we are starting from zero, so definitely both quantities will increase. So initial after velocity, initial velocity, your final velocity will increase from the reference point, and your acceleration will also increase. And free fall motion means there is one natural force, we can say that that is the force of gravity. So due to that gravitational pull, object is going to move in downward direction, right? So free fall motion means when an object moves under the influence of gravity, acceleration due to gravity, right? So this is the
Yes.
basic concept, because we are not going to write the definition exam, because they never ask about the definition of free fall motion. Okay. The next thing is, this is the initial stage. We are going to divide this whole motion into two or three stages, because there is very important concept of terminal velocity included in this section. That is very much important, because in worksheet, you also observe that many questions are related to terminal velocity parachutist, terminal velocity paraglider, like this. Okay. So if we talk about at the first
Okay.
stage, let's suppose we consider this as phase one. This is only for your understanding. This is not part of the topic phase or phase two. This is only for our reference. Phase one means this phase, right? So we start moving from the rest state. So it means that your velocity will increase at phase number one. Velocity will increase plus your acceleration will also increase. is there are two forces, because one force is naturally acceleration due to gravity or gravitational pull is present over there. So about the gravitational pull, so there is an other force which always act in the opposite direction, that is the force of air resistance, right? So air
Okay.
resistance is the force. In your past we also find, right, in terms of forces, what forces and how forces are going to be act in free fall motion, right? So that is very important part. You need to know that where air resistance will act increasingly, decreasingly, or constant. So your air resistance will also increase, and we know that weight remains the same because on certain planet or certain surface your value of weight remains constant. Air resistance will increase to balance the weight. Okay. And one more thing that I need to mention over here, that at this phase your weight is greater than air resistance, right?
Okay.
Our phase one. And let's suppose if we consider the same ball after some interval, let's suppose at this point, so this will be our phase two. So now in, if we consider the example of a paper, right? If we take paper and we make a ball of that paper, right? And again we take another paper, there are two pieces of paper. From one paper we make a ball, from second paper we take it simple in a plain form, right? And if we drop both paper from same height, so what will happen?
The ball one will fall down faster.
Yes. So paper ball will fall faster, because but both are made of same material, right? But it's still there is a difference in their surface area, right? The flat paper has great surface area, so air resistance quickly balance the weight of that paper, right? But when we consider the example of a paper ball, so in paper ball, the surface area is less, and air resistance needs some time to balance the weight of that paper, right? So initially we start
So
from.
do they still have the same weight?
Yes, they have same weight because all mass is concentrated at one point and all weight is acting in downward direction. So both have same weight, right?
Oh, okay.
Yes, because if you observe the paper packet of that printing paper, A4 size, A3 size, so there is a mass of each paper written over there, 70 GSM, gram per centimeter, gram per millimeter, like this. So we can easily measure the weight and mass. We use digital balance or very sensitive balance to measure the mass of that paper, right?
Okay.
Okay. So this is the concept, right?
Okay.
So next thing is at the phase two. Now air resistance have enough time interval to balance the weight, but at this stage or after some time, air resistance tries to balance the weight of that object, right? But before that, if we talk about the velocity and acceleration, because initially velocity starts to increase and acceleration is also increasing, right? But after some time, when air resistance tries to balance the weight of a body, so what change we are going to occur in velocity and acceleration, right? So before writing about phase number two, I am writing an important point over here. Uh, that is not related to our phase, that is during or the path between phase 1 and phase 2, right? And this phase is, I am again repeating that this is for your understanding level. These phase are not going to be included in your any specific section, right? This is just for your understanding. So before reaching phase 2, air resistance, I am writing in short air, capital R, air resistance, right? Air
Okay.
resistance will increase and try to balance the weight of the body. It means that at this stage it almost balances the weight, not completely, right? Like 80-90% it balances the weight. Try to balance the weight of a body. But in meanwhile, what is our main concern in this section? We need to talk about velocity and acceleration. Now you know that when air resistance is going to be increased, so your change in velocity is now slower as compared to the phase one, right? Because initially we start from zero, so we will get maximum change in speed. But now when air resistance tries to balance the weight of the object, so your change in velocity is now going to be slowed down, right? So that is the important part. So change in velocity will decrease. It means that, in short, that your acceleration will decrease as compared to phase one, right?
Okay.
So actually it means that acceleration will decrease as compared to initial condition, right? So this thing between phase one and phase two. Now let's talk about phase number two, because we need to write about forces, and we need to talk about the quantities. So let's suppose phase two. Let's suppose now at phase two we consider that weight and air resistance both balance each other, right? Because before that scenario we already have paragraph regarding the air resistance and weight. So now let's consider that both will balance each other. So at this stage, your velocity is going to be constant, right? Because all forces are now balanced. And all forces are balanced, so it means that your forces are balanced. And if we talk about the so for acceleration, what is your acceleration? When your velocity is constant, so what will be the value of acceleration? Any idea?
It will be increasing.
Think again about it. Let's suppose if velocity is constant, think about that velocity time graph. I will show you. This is your graph. Speed time, yes. So let's suppose if we talk about this graph, and when your speed is constant, this first graph, so what will be your acceleration? You also solve this question in a topical sheet.
Constant.
Constant or zero? Two things are different.
Oh, it will be 0.
Yes, because the speed is constant. So by definition, we know that acceleration is rate of change of velocity. So if your velocity is not changing, so it means there will be no acceleration. So weight is equals to air resistance, because now air resistance balances the weight of the body. So your acceleration will be equal to zero. And there is a very important concept in this whole free fall motion, and that concept is related to that constant velocity. This constant velocity during free fall motion is known as terminal velocity, right? Because we also
Okay.
velocity concept in linear motion while driving a car, while moving or running from one point to another. But during free fall motion, it is a complete different concept of terminal velocity. But still, the basic difference is the same, that this velocity means that it is a constant velocity during the motion, right? So what is actually
Okay.
terminal velocity? We can write it as, it is a constant velocity. Again, this definition is not going to be included in your exam. I'm writing just for your reference. So that will help you to understand after you are going to review these notes. So constant speed during free fall motion.
So terminal velocity is reached when the velocity is constant.
Yes, but during free fall motion, only special case, right?
Okay.
So during free fall motion, constant speed when balanced, right? And we know there are only two cases in this scenario. So this scenario and this special case is related to the terminal velocity, and this concept is normally happen with the paratroopers or the parachutists. that actually jump from the height, or they just use parachute or paragliders to fly, we can say that, in air, or to move from the height to the ground level, right? So that is the concept. Okay.
Okay.
And let's suppose if we take the example of a parachutist, right? So when parachutist jump from the height, so first it reach its original terminal velocity when he tries to balance itself, right? Okay.
Okay.
Let's suppose if we continue the same example with parachutist, right? We jump from the height, body, you also observe that when parachutists jump from the height, so they just open up their whole body, they increase their surface area, right? So that will make easy for them, so air resistance will easily balance the weight of the body in short time interval, right? And after that, when the air resistance balance the weight of that body, and then they opens up the parachute, right? So if we consider, and if we continue the same example with the parachute, so let's suppose we are having a parachute with that person, and that parachute opens, right? We jumps from a height, we reach our terminal velocity, and then we suddenly opens a parachute, right? What you observe over there, any idea? Let me show you, so that will make easy to understand that what actually I am talking about. Terminal velocity parachutist. Okay, screen is visible, right?
Yes.
Okay, I am talking about this concept. Let's suppose if someone starts to, this is our maximum height, right? And when a parachute starts to jump from the initial point, initially we have initial velocity equals to zero. Our initial speed is completely zero, and we jumps. So after jumping from our initial stage, you know that our velocity and acceleration starts to increase, right?
Yes.
So this is the first phase when your speed is actually increasing. And you can also see on the left bottom corner, weight, drag, velocity, acceleration are mentioned over there. Drag means air resistance, right? So
Oh, okay.
arrow will show you that green means your there are two arrows in drag direction, and there are three arrows with the direction of weight. So it means that your weight is still greater. Phase number one, right? Okay. And after some time, you observe that now we have three arrows in upward direction, three arrows in downward direction, right? So it means that all forces are now balanced. Okay.
Okay.
This is the first stage that we studied in our free fall motion, this one. Okay, phase one, phase two. Now we consider the second scenario when parachutes open. Now let's observe that thing. Now you can see that body is moving with constant speed, right? Because there is no change in the movement. It is completely like a stable, constant movement, right?
Yes.
And when he opens up the parachute, then that's our important part that we need to discuss. Yes, this is the part. What really happens? Let's try to move in slow motion. Uh, Playback speed. Yes. Now what you observe that when he opens up the parachute, so what actually happens? It again moves in the upward direction, right? Initially, he was
Yes.
moving in downward direction, but after opening the parachute, he moves in upward direction, right? So moving in upward direction means your air resistance is now greater as compared to the weight, right? Because body will move in that direction where force is greater, right?
Oh, okay.
Yes. So actually, this is the second scenario if we continue with the parachutist example. If we are not moving with the parachute, so that is, there are two phases only. that we discussed. But when we open up the parachute, so what actually happens, we have a huge surface area as compared to the previous situation, right? So what actually
Okay.
happens over there, that your air resistance is now greater than the weight, right? And what happens with the velocity? We are moving with constant speed. So what actually happens with the speed and acceleration? Your velocity will increase or decrease?
It will decrease.
It will decrease, because initially we are moving in downward direction, just like if car is moving in forward direction, suddenly you applies brakes, so what happens, your velocity will decrease, and again acceleration will produce, and acceleration will also greater, right? Because there is a change, quick change in speed. So when there is a quick change in speed, so your acceleration will be greater, right? So if we write with acceleration, so initially acceleration is zero when there is terminal velocity, but this time your acceleration will increase, right? Why I am writing increase? Because if we compare with the previous situation, so here we have zero acceleration, right? And a constant velocity. But after opening up the parachute, your velocity will decrease, but your acceleration will increase because of that huge air resistance, right?
Okay.
Clear? Any confusion?
No.
Okay, and after opening the parachute, after some time, your speed is going to be again constant. So that is the new terminal velocity with the parachute. Okay, initially we reach terminal velocity with the body, and after that we reach terminal velocity with the help of parachute. Right now they are
How
moving.
do they come down? If like whenever we open the parachute, we go up. So how do they come down with the parachute?
Okay,
Like on.
actually, yes, actually, when parachutes open, so suddenly we are getting a huge surface area, and air resistance suddenly increases, right? But we know that gravitational pull is much stronger than the air resistance, right? So that's why our
Oh,
body will always move in downward direction, but it will take time, because when suddenly someone pushes you, let's suppose if you are standing at your rest state and suddenly someone pushes you from the back side, so what will happen? You will take time to balance your body again, because you don't know that who is going to push from the back side or from the front side, right? So that is the same
okay.
condition with this parachute, that suddenly someone pushes parachute in upward direction. Then again, gravitational pull takes a small time interval, and again it balance the body, and then body will again move with the concept of terminal velocity, right? So that is our
Okay.
second phase with the parachute. This is phase number one with the parachute. This is phase one with the parachute. And if we talk about for phase number two, so phase number two will be now again your air resistance will be equal to the weight of a body, and again your velocity will be equal to what? Constant.
Yes.
Velocity will be constant over here, and your acceleration will be
Zero.
zero, right? It means that again you are getting your terminal, right?
Yes.
So this is phase number for parachutist, right? With parachute, we can say that, because we studied air resistant terminal velocity in two phases, without parachute and with parachute. I split this topic in two different forms, so that will be easy for you to understand. Otherwise, it is a difficult one to understand, because there is a terminal velocity concept two times. So sometimes you got confused that which one is the terminal, because there are two times velocity balances the weight. So that's why I split this topic into phases, but these phases are not important to write in paper. The only concept that you need to study is that how weight and air resistance will balance each other during free fall motion. So that is the important part only. Okay.
Okay.
And let's suppose if you want to draw a graph for this whole scenario, so your graphical representation will be on a single graph for whole journey. So that is also the important part, because you also observe a graph in your worksheet. There are graphical questions also included in your worksheet. So let's suppose if we talk about the graphical representation. So let me show you the graphical representation. And we need to draw a speed time graph, right? Not distance time graph, because our main concern is to discuss the terminal velocity, constant speed, right?
Okay.
So let me draw a graph. First of all, let's choose two axes. And you know that on x-axis always there will be independent quantity, and dependent quantity will be on y-axis, right? So according to the graphical representation, time will be on x-axis. And the second thing, speed is on y-axis. Now let's draw first the graphical representation, then we write the important points. First of all, we are moving with increasing speed, right? And speed is constantly increasing, right? Initially. So there is a change in speed, but that is constant. So for very short time interval, we move in a straight line like this. Then there will be a change and our velocity is going to be constant, right? Like this. And if you remember those
Okay.
graphs, so you got the concept how this graph is going to be change its direction. And at this specific point, we suddenly opens the parachute, right? And our speed will suddenly fall towards zero, not complete zero, but it start going towards zero, means in downward direction. So then there will be a quick change. So there will be a quick change in a very short time interval. So there will be a slightly curve in the graph. Then again, it balances the weight, air resistance, again, we are going to move with constant speed, right? And after some time, we reaches the ground surface, so that will be the zero speed. Okay, clear?
Okay.
Okay, now if someone asks you to interpret, write important concept to the, let's suppose we just divide this whole graph into small components. So at this particular stage, when there is a straight line, so in this particular stage, we can say that your weight is greater than air resistance or drag, right?
Okay.
Because this is the initial stage. This is our phase one. I am writing P1 means phase one. This is phase one before uh, without parachute, right? And the next thing,
Yes.
after some time, you observe that your speed is going to be equal, or this part, the constant line shows you the concept. Now air resistance is completely balanced by the weight, or weight is to be balanced with the air resistance, right? And you also know the concept of speed and velocity, that your speed is constant but your acceleration is equal to zero. And the first phase for the increasing part, right? And at this
Okay.
point, now we move towards the next phase that is related with the parachute. This is our phase two. And at this point, we open the parachute of our parachute. And after that, we also have two phases with the parachute, and that is linked with this one. So now air resistance suddenly increases. So that's why there is a great fall in your graph. So air resistance, like there will be a mighty change in air resistance as compared to the previous situation. So that's why there will be a huge change in it, right?
Okay.
And after this, what we observe that again we are going towards the constant speed. So again, one more time, air resistance is going to be equal to the weight of the body. So that will be our phase two with the parachute, right? So this is our phase one with the parachute, and our phase two with the parachute. So times we are getting our terminal velocity in this graph. First one over here. We are getting our terminal at this point. And the next thing is this one. At this point, we are getting terminal velocity, right?
Yes.
Any confusion?
No.
So this is the concept of free fall motion. Uh, so in this situation, we can say that the air resistance balances the weight of the body during free fall motion, and that balanced body is known as to be moved with the constant speed, and that constant speed is known as terminal velocity, right? And one more
Yes.
important thing is, you know that how to calculate the weight of a body, that we also going to be discussed in the chapter of mass, weight, and density. But generally, let's suppose if you want to calculate the weight, so formula is very simple: W equals to mg, right? And the
Okay.
value of g gives you the concept like this, that this value of g explains you acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity means you know that value 9.8 meter per second square or 10 meter per second square, right? Okay, before the examination series of 23 May June 23, the constant value mentioned in your paper is 10 meter per second square, right? But in new updated series after starting from 23 till 25, we are having a constant value of g written in your paper that will be equal to 9.81. So now we are going to use 9.81 meter per second square as the value of g every time, right? So that is also a change in your syllabus. Okay.
Okay.
So when we discuss this chapter of weight, so we also discuss this value of again. That is very common to use in many formula, because that is very general term and that is very common value that mostly we use in our questions and mostly we use in our concepts. So that is the concept of terminal velocity. Any question or any confusion in this situation?
No.